What if everything you thought you knew about the physical world was, well, fundamentally backwards? I want you to just completely abandon the classical idea of physics for a second. Forget about static matter just sitting around in some empty vacuum. Instead, consider this. What if reality itself is an active, ongoing computational machine? What if physics is actually just the cost of running math? Okay, let's dive into this. In the classical, sort of object-oriented worldview, we've always treated the universe as a noun-based reality, right? Physical particles with static definitions. But the Nexus framework proposes something radical, called an ontological inversion. It suggests the universe is actually governed by the absolute rule that verbs are greater than nouns. In this view, matter is literally just cached verbs, and the universe isn't a passive vacuum at all. It is the computational substrate itself. Welcome to The Explainer. Today, we're going to completely shatter your standard understanding of reality. We are looking at some truly mind-bending research on how the universe acts as a massive, constraint-resolving computational engine. Honestly, get ready to never look at a physical object the exact same way again. Here is our roadmap for today's Explainer. First, the ontological inversion. Then, we'll look at push and turn dynamics, followed by heat as algorithmic exhaust. After that, time is a search ledger, and finally, we'll wrap up with the dielectric gap. All right, let's jump straight into section 1, the ontological inversion. It's time to challenge what a physical object actually is. Physics is what mathematics costs to run. Just take a second to think about the sheer awe of that statement. You see, a static mathematical theorem is totally timeless, and it's energetically free. It can just sit there at a domain boundary forever, costing absolutely nothing. But the exact moment you execute that logic, the moment you advance a state or compile a next step, boom, you introduce time, energy, and irreversibility. Physics is quite literally born as the execution price of that math. I want you to look at your hands for a second. Seriously, look at them. According to this framework, you aren't looking at static nouns. You are looking at high-frequency loops of math resolving constraints. An electron isn't some tiny, solid billiard ball. It's a frozen verb. It's a persistent, active loop of computational operations that maintains a stable physical identity by constantly rotating and collapsing. You, my friend, are made of actions, not objects. Which brings us to section 2, push and turn dynamics. Let's look at the core mechanism of how this computational universe actually moves and forms structure. First up, we have push. Push is the external forcing that drives a system. It's the brute force builder of the board. Think of it like the violent asteroid bombardment of a young planet before it can ever hold a stable atmosphere. Push deposits energy, it physically reshapes the constraints, and crucially, it pays an unavoidable thermodynamic tax. It creates the raw physical substrate. But here's the thing. Push alone would just thermalize and burn itself out. It needs a twin. Enter the turn. Turn is the internal evaluation a system performs against its own constraints. It changes representation by rotating coordinates, but it perfectly conserves an invariant system property, which means it doesn't spend energy. If push is that violent planetary bombardment, turn is the elegant, delicate chemistry that can finally happen once the bombardment stops resurfacing the crust. And this brilliantly illustrates how they loop together to create complex reality. The universe basically functions as an algorithmic engine. Step 1, it propagates, pushing forward. Step 2, it evaluates and rotates, which is the turn, searching for an efficient path. And step 3, when it absolutely can't resolve the logic reversibly, it collapses. It makes a hard commit and pays that thermodynamic tax. This cycle just repeats infinitely to build all the structure we see around us. Let's move on to section 3, heat as algorithmic exhaust. We are taking that abstract math and linking it directly to why a fire actually feels hot. Now, what's really interesting about this slide is how the framework grounds everything in established thermodynamics, specifically Landauer's principle. This principle states that erasing one single bit of information physically dissipates a minimum amount of energy as heat. So heat isn't just random kinetic friction. It is literally algorithmic garbage collection. The math behind this reveals some explosive exponential numbers. When a computational system performs a blind search, just guessing and checking without any structural shortcuts, it has to physically erase every failed attempt from its register. As the secret bits increase from 8 up to 20, the pool of candidates grows, and the mean bits erased skyrockets from roughly 1,000 to over 10 million. It's wild.
This proves the severe thermodynamic cost of doing a blind search versus a clean, reversible computation. This leads us right to the paradox of garbage. If the universe perfectly remembered every single logical step it ever took, its logical depth would completely freeze. It would lock up under its own combinatorial weight. So, to keep functioning, the universe physically sheds heat to clear its memory. Heat is just a structured, causal transcript of erased math. And get this, even black holes follow this rule. Hawking radiation is now understood as the literal Landauer-mandated thermal exhaust from erasing information right at the event horizon. How cool is that?
Okay, Section 4, time is a search ledger. This is probably the most mind-bending concept we're covering today.
There is a very specific number you need to know, 1.000. In the research, if you take the mean ticks of a system and subtract the number of informational erasures, it exactly equals 1 every single time. It's an absolute identity. What this implies is that time isn't some fundamental dimension stretching out into the future. Time is literally just a burn count of rejected computational guesses.
So the crucial point is this: time does not flow. Clocks do not measure a river of time passing us by. They merely count the accumulation of localized forced state changes. Time is simply the thermodynamic cost of algorithmic forgetting. It's the ledger of the search. Physical time is literally just the cost static logic pays to execute its next state.
Finally, Section 5, the dielectric gap. This is the final piece of the puzzle: why the universe doesn't just instantly resolve all computations and immediately end.
The secret is that a boundary is strictly required between the computational reader and the writer. If an observer could perfectly see the whole system at once, achieving 100% computational efficiency, it would cause a degenerate short circuit. You'd get x equals f of x, and it would lock the universe completely. So, to protect its own continuation, the universe maintains a relational gap. It acts just like a physical dielectric in an electrical circuit. This residual error, this fundamental imperfection, is exactly the mechanism that enables existence to persist. To compute reality is to cross the gap. The entire cosmos, from the tiniest quantum states all the way up to macroscopic biology, persists strictly by computing across these gradients. It survives by actively resolving its inherent dimensional conflicts at every single scale, pushing across that gap without ever permanently closing it. We've covered some genuinely incredible ground today in this explainer, from realizing that physics is basically just the runtime of math, to seeing heat as erased data, and understanding time as a ledger of rejected transitions. I want to leave you with this final provocative thought. If your physical body is really just a high-frequency loop of cached verbs, what computations are you executing right now? Think about that and keep your curiosity alive.